For more than 20 years, one American aircraft has remained one of the most closely guarded symbols of air superiority, the F-22 Raptor. It first entered operational service in December 2005. And yet, 2 decades later, the basic question remains fascinating. If China has become one of the world's fastest-growing military powers, why hasn't it simply built its own F-22? The answer is more complicated than copying an aircraft's shape. Because the Raptor isn't just a machine. It's a combination of technologies that took decades to develop. Stealth, supercruise, extreme maneuverability, advanced sensors, and one of the most sophisticated propulsion systems ever placed inside a fighter. And that combination is what makes the F-22 so difficult to reproduce. China did not ignore America's fifth-generation fighter advantage. Instead, it developed its own stealth aircraft, the Chengdu J-20. The aircraft is a major achievement in Chinese aerospace engineering and has become an important part of the People's Liberation Army Air Force. The Pentagon has reported that China has been increasing J-20 production and working to expand its domestic aircraft engine capabilities. So this isn't a story about China being unable to build a stealth fighter. It clearly can. The real question is different. Can China reproduce the exact technological balance that makes the F-22 unique? Because looking like an F-22 is the easy part. Understanding everything underneath the skin is much harder. The first secret is stealth. And stealth doesn't simply mean making an aircraft look angular. A stealth aircraft must control how radar energy interacts with almost every part of its body. The shape matters. The alignment of surfaces matters. The treatment of gaps and panel joints matters. The materials matter. Even the engine exhaust and the way air enters the engine can affect the aircraft's radar signature. The F-22 was designed around this principle from the beginning. Its geometry, materials, and systems were developed together. That is important because you cannot simply download a blueprint and instantly reproduce the result. Even if an engineer knows the theoretical shape, the manufacturing process still has to reproduce thousands of tiny details consistently. That is one reason stealth technology is as much about manufacturing precision as it is about mathematics. And this is where copying becomes extremely difficult. But perhaps one of the Raptor's most important advantages isn't visible from the outside. Its engines. The F-22 uses 2 Pratt & Whitney F-119 engines, and these engines allow the aircraft to supercruise. That means the Raptor can sustain supersonic flight without relying on afterburners. The difference is enormous. An afterburner can produce tremendous additional thrust, but it also consumes fuel at an extraordinary rate. Supercruise allows the F-22 to remain supersonic while avoiding that constant fuel penalty. The U.S. Air Force says the Raptor can cruise above Mach 1.5 without afterburner. That gives the aircraft a larger operating envelope and can allow it to reach an engagement area faster while preserving fuel. But building a powerful engine isn't enough. The engine must also be reliable, light enough, compact enough, efficient enough, and powerful enough to perform under extreme conditions. That combination is one of aerospace engineering's hardest problems. Then comes maneuverability. The F-22 doesn't rely only on aerodynamic surfaces to control its movement. Its engines use thrust vectoring nozzles. In simple terms, the aircraft can redirect engine thrust. Imagine holding a powerful jet of air in your hands and changing its direction. That is essentially what thrust vectoring allows the aircraft to do. Combined with its aerodynamic design, flight control computers, and high thrust-to-weight ratio, the Raptor can perform extremely aggressive maneuvers. The technology isn't new anymore, but integrating it successfully into a stealth fighter is incredibly difficult, because every decision creates another engineering problem. More moving parts can affect reliability. Engine performance affects stealth. Stealth affects the exhaust design. Exhaust design affects heat management. And weight affects everything. The F-22 was designed as a system, not as a collection of independent technologies. But the most important weapon on the F-22 of May not be its missiles, it may be information. The Raptor combines radar, electronic warfare systems, communications, and other sensors into an integrated picture for the pilot. This concept is known as sensor fusion. Instead of forcing the pilot to interpret several independent systems, the aircraft combines information into a clearer tactical picture. That can create a critical advantage. The pilot who sees the threat first can potentially make the first decision. And the aircraft that can detect, identify, and engage an opponent before being detected itself has a major advantage in modern air combat. The U.S. Air Force describes this combination of sensor capability, integrated avionics, situational awareness, and weapons as central to the F-22's first kill opportunity. This is why the Raptor isn't simply a stealth airplane, it is a flying information system. So why can't China simply copy the F-22? The first problem is that a modern fighter is not one invention, it is thousands of inventions working together. Suppose you obtain the basic shape. You still need the right materials, the right manufacturing tolerances, the right radar-absorbing treatments, the right software, the right flight control algorithms, the right radar, the right electronic warfare systems, and perhaps most importantly, the right engine. A blueprint can tell you what something should look like. It doesn't necessarily tell you every reason it works. And modern aerospace technology depends on decades of testing, wind tunnels, flight tests, material experiments, engine testing, failures, redesigns, and classified lessons learned from every previous generation. According to the U.S. Air Force, the F-22 development program involved enormous amounts of aerodynamic testing and material trials before the production aircraft emerged. That accumulated knowledge is difficult to reproduce quickly. But there is an important point that often gets lost in sensational headlines. The J-20 should not be treated as a failure. It is a serious fifth-generation fighter, and China has continued improving it. The aircraft's design reflects different priorities. Its large airframe and long-range characteristics suggest an emphasis on operating over significant distances and threatening high-value targets, such as support aircraft. So comparing the J-20 and F-22 as if they were identical products may actually be misleading. They belong to the same broad generation, but they were developed around different strategic requirements. And China isn't trying to freeze its technology at the level of the first J-20. It continues to develop new engines, sensors, and aircraft systems. That means the real competition isn't who copied whom. The real competition is who can innovate faster. And this may be the biggest lesson of the F-22. The United States didn't create it overnight. The program traces its roots back to the Cold War era. The YF-22 prototype first flew in 1990. The first F-22 test aircraft followed in the 1990s. After years of development and testing, the Raptor finally entered operational service in 2005. That's roughly 2 decades of development before it became an operational weapon. And the technology behind it began even earlier. So when people ask why another country hasn't simply copied the F-22, the answer may be hiding in the question. Because advanced military technology isn't just a product, it's an ecosystem. Scientists, engineers, factories, materials, software, testing facilities, suppliers, flight crews, and decades of accumulated knowledge. After more than 20 years, the F-22 is no longer America's newest fighter, but its technological legacy remains. China has built its own fifth-generation aircraft. Russia has developed the Su-57, and the United States is already looking toward the next generation of air dominance. The F-22's greatest secret was never one magical component. It was the ability to combine stealth, propulsion, maneuverability, sensors, and software into one highly integrated machine. And that may be the hardest thing of all to copy, because you don't copy 20 years of engineering experience in 20 years. You have to build it, test it, break it, improve it, and start again. The F-22 Raptor proved that air superiority isn't just about having the fastest aircraft or the most powerful missile. Sometimes the greatest advantage is simply seeing the enemy before the enemy sees you. This is Skywatch World, and the race for the future of air power has only just begun.